Welcome to part 1 of integration. Find a primitive function of 3x minus 4. So to do this, let's first write out our equation. The integral of 3x minus 4 dx. Now, let's find out what this would equal to. The integral of 3x. For derivatives, we know we must times and then minus. Now, for integrals, we must do the opposite. We must add and then divide. This is regarding to the exponent of the value of x. So, in the integral of 3x, we know x has a power of 1. So we must add another 1 to the power. So it would be 3x to the power of 1 plus 1. Now, this will be equal to 3x to the power of 2. That is our component of adding for integration done. Now, let's divide this integration. 3x squared. We know our new exponent is 2, therefore we must divide by 2. That is how to integrate 3x. So let's write that down. 3x squared over 3 minus 4. So for any constant, the integration would always be the constant times x. In this case, our constant is 4. So the integration of 4 in this case would be 4x. Now, I'll show you why this is true. We must add 1, which would be x, and then divide it by 1 due to our new exponent. Therefore, it would be 4x. So, 3x squared over 2 minus 4x is the integration. However, in the question, it says primitive function. For primitive functions, we must always add c to the end of the integration to represent a constant value. Let's try a similar question to this. Find a primitive function of 16 minus x squared. Now, the integration of 16 minus x squared dx. Let's calculate this. The integration of 16, as we have learned in the previous question, would always be the constant times x. Therefore, the integration of 16 would be 16x. So let's write this first part down. 16x minus the integration of x squared. Now let's calculate the integration of x squared. So our previous rule for integration is add and then divide. So for this particular example, to x squared we must add 1. So 2 plus 1 would give you x to the power of 3. That is our addition part done for this question. Next, we must divide. So, since our new power is 3, dividing it will give us x to the power of 3 and then divide it by 3. So our integration of x squared is x cubed divided by 3. However, the sign will always remain the same. In this case, it would be minus x cubed over 3. Since it is a primitive function, we know that we must add a constant of c. Therefore, our final answer would be 16x minus x cubed over 3 plus c. Let's try a different type of example. The integral of 3x minus 1 to the power of 5 dx. So in these types of questions, we must use U-Substitution. There are many different ways to find the integration of a particular equation. So for U-substitution, let's write U is equal to 3x minus 1. Now for U-substitution, we must find the derivative of the u side and the x side. So du would be equal to the derivative of 3x minus 1, which is simply 3 dx. Now let's solve for dx, so our final answer for dx will be du over 3. Now let's sub this back into our integration. So the integral of 3x minus 1 to the power of 5 dx will become the integral of u, since we substituted u as 3x minus 1, to the power of 5 du over 3. It is du over 3 since we know dx is equal to du over 3. Du over 3 is simply 1/3 times du, so we can bring the 1/3 to the front of the equation. Therefore, it would give 1/3 integral of u to the power of 5 du. Now, just like before, let's use our integration rule, and we know that we must add and then divide. So 1/3 of the integral u to the power of 5 will be u to the power of 6 divided by 6. Now, since the original question involves the letter x, we must write the answer in terms of x. So let's sub back the value of u. So it would be 1 times u to the power of 6, which is also equal to 3x minus 1 to the power of 6 divided by 6 times 3, which is 18. However, in these integration questions, we must always add a constant of c. This will be your final answer. Now, let's try equating an integral. The integral of 2x to the power of 5 plus 1 dx. So let's find the integral of 2x to the power of 5 first. Now, we know the rule is add and then divide, so let's add 1 to 5. 2x to the power of 5 plus 1, which is 6, divided by 6. We can simplify this to become x to the power of 6 over 3. So let's write this down. The integral of 2x to the power of 5 would be equal to x to the power of 6 divided by 3. Now, let's find the integral of 1. In our previous questions, we have understood that the integral of a constant would always be constant times x. Therefore, the integration of 1 is equal to x. Now, we already know our limits, which are 2 and 0. All that is needed is to sub this back into our equation that we have. So, 2 to the power of 6 divided by 3 plus 2, and then for these we must minus the limits. So since we have already used 2, let's minus the 0 limit. So open bracket, 0 to the power of 6 divided by 3 plus 0. Now you can either do this in your head or you can sub it back into a calculator. So putting this into our calculator, you know that the 0th segment of this equation will remain as 0, so our final answer will be equal to 2 to the power of x over 3 plus 2, which is also equal to 70 over 3. Now looking back at this question, it says find correct to 1 decimal place. So let's plug this back into our calculator and find 1 decimal place. Therefore, your final answer would be 23.3. For these questions, whenever you write to a certain decimal place, make sure you write in brackets to how many decimal places. In our next question, it says to find the integration of x minus 1 to the power of half dx. So similarly, like before, let's use U-Substitution. U will be equal to x minus 1, du would be equal to the derivative of x minus 1, which is simply 1 dx. So du will be equal to dx. Now let's sub our new information back into the question. So the integration of u, because u is equal to x minus 1, to the power of half du. Now let's continue solving this. Remember our rule from the beginning of this video. We must add and then divide. So add 1 to half. This will give you u to the power of 3 over 2 divided by 3 over 2. Now try and simplify this yourself and see if it matches my answer. This would be equal to 2u to the power of 3 over 2 divided by 3. Therefore, the integral of u to the power of half will be equal to 2u to the power of 3 over 2 divided by 3. Now, since the question is given in terms of x, let's find out our final answer in terms of x. Since we know u is equal to x minus 1, let's sub that back in for u. So 2 over 3 into x minus 1 to the power of 3 over 2. This will be your final answer plus a constant of c, because remember, what we are solving for are all primitive equations. Our next question, the curve y is equal to f of x has gradient function dy over dx is equal to 3x squared plus 4x minus 1. The curve passes through the point P 1, 0. Find its equation. For these types of equations, we must find the integration of the gradient function. So, the integration of 3x squared plus 4x minus 1 dx. So now let's find the integration of 3x squared. Now, from before, we know for integration we must add and then divide. Therefore, the integration of 3x squared will be equal to x cubed. Now, for the integration of 4x, it would be 4x squared divided by 2. Simplifying this, it would simply give us 2x squared. Remember, the symbols stay the same. From previous examples, we know the integration of a constant is x. Therefore, it would be minus x, and then an addition of a constant. Now, looking at the question, we know we have a point 1, 0. So let's sub this back into our equation. 1 cubed plus 2 times 1 squared minus 1 plus c would be equal to 0. This is because in the coordinates, x is equal to 1 and y is equal to 0. Now, let's solve our equation for c. 1 cubed is 1, 2 times 1 squared is 2, minus 1 plus c is equal to 0. Therefore, our final value for c will be equal to minus 2. We used the point to find a constant. A constant is what appears after every integration. So, since we know our constant, we can write f of x is equal to the integration of dy over dx, which was x cubed plus 2x squared minus x plus c. However, we know c is equal to minus 2. So f of x will be equal to x cubed plus 2x squared minus x minus 2. Now, let's try a similar question. The graph of y is equal to f of x passes through the point 1, minus 1, and f prime of x is equal to 3x squared plus 2. Find f of x. Now, similarly like the previous question, let's find the integration of the derivative function. So now, let's find the integration of 3x squared plus 2 dx. The integration of 3x squared will be equal to 3x to the power of 3 divided by 3. Simplifying this, we get the integration of 3x squared is x cubed, plus the integration of 2. Since we know the integration of a constant is the constant times x, it would be 2x plus c. Now since we are given a point, let's sub this back into our equation. 1 cubed plus 2 times 1 plus c will be equal to minus 1. This is because the x value is 1 and the y value is minus 1 in the coordinate. So let's simplify this. Minus 1 will be equal to 1 cubed, which is 1, plus 2 times 1, which is 2, plus c. So, our final answer for c will be 2 plus 1, which is 3, minus 1, which will be minus 4. Therefore, using our derivative function and then integrating it, we know f of x is equal to x cubed plus 2x plus c. However, we now know the value of c. Therefore, our final equation for f of x will be equal to x cubed plus 2x minus 4. Now let's try a different question. Find the area between the curve y is equal to 1 over 1 minus 2x squared. The x-axis and the coordinates at x is equal to 0 and x is equal to 2. So for these types of questions, to find the area beneath the curve, we must use integration with limits. So let's find out the integration of y is equal to 1 over 1 minus 2x squared. This can also similarly be written as y is equal to 1 minus 2x to the power of minus 2. So let's find the integration of this. For these types of questions, I prefer using U-Substitution. So let's write u is equal to 1 minus 2x. du would be equal to the derivative of 1 minus 2x, which is minus 2 dx. du over minus 2 would be equal to dx. So let's sub this back into our integration. So, du over minus 2, as we know now, is equal to minus half times du. So let's write minus half at the front of our integration. So minus half integral of u to the power of minus 2 du. The integral of u to the power of minus 2 would be u to the power of minus 2 plus 1, which will give you minus 1, divided by minus 1. So let's write this down. Minus half times u to the power of minus 1 over minus 1. However, we now know the limits in this question are 2 and 0. If the question does not say, always write the larger value at the top of the limit. So, u to the power of minus 1 divided by minus 1 can also be written as minus u to the power of minus 1. This would be equal to minus half with limits 2 and 0. So inside of the brackets, we would write minus 1 over 1 minus 2x, close the bracket. Now, let's substitute the values of 2 and 0 into this. So minus half times minus 1 over 1 minus 2 into 2. This would be our first part for our first limit. So then we must minus it by our second limit, which is 0, which would be minus 1 over 1 minus 2 times 0, and then big close bracket. So you can either put this into your calculator or calculate this into your head. You should get a final answer of negative 2 over 3. For these types of questions, you must always take the absolute value of the answer you get. The reason behind this is because you cannot have a negative area. So by taking the absolute value of negative 2 over 3, you should get a final answer of 2 over 3. Remember to always write units. In this case, our units would be 2 over 3 units squared. That's it for today's video. Hope you learned something. Like and subscribe if you want more content like this.